Okay, so I'm going to go through this similar to what I've done with the last two exercises. It'll be interesting to get your feedback on whether this is more useful or not. But okay, so this is new stuff. We're talking about a function. So it's not really that new, but a function cannot contain two different ordered pairs with the same first coordinate. So we're thinking about first coordinates. Okay, so that's our x value. So it can't contain the same x values. Okay, so it'll become more clear when we see some pictures and some questions. And we've got what we call a vertical line test. So if you can draw a vertical line, so an up and down line through a graph, and it only cuts it once, okay, then we know it's a function. So let's jump across to the exercise here. So which one of the following relations are functions? And state the domain and range for each. So if we have a look at this, is it a function or not? So straight away, we've got to make sure that our x values are all different. Well, looking at those first two, this automatically scrubs it off. So that's not a function. Let's have a look at this. We've got a -2, -1, 0, 1, 2. So this one here is definitely a function. If we're going to state the domain, then obviously we just state all the x values. The range will be all the y values like we did at, I think, the first question of 5b. This one here, I'll let you figure it out whether they're domains, whether they're a function or not. So question 2, we actually have to sketch some of these, state the range, so that's exactly what we've done in 5b. But the only other thing that's we've got to do is whether it's a function or not. So after you've sketched it, if we think about it, if you draw a vertical line, will it go through it? This is a circle, okay, but we've got a restricted domain. So it's only 0 to 2. So really, it's only going to be a quarter of a circle if you think about that. So our x can only go from 0 to 2. So it's still going to be a function. So this domain will affect whether it's going to be a function or not. So the domain here is very, very important. Okay, so I've done this down here. So 2a, I've sketched the graph. There's my vertical line. So I can easily say that it is a function because it satisfies the vertical line test. We've got a graph. I know this is a straight line, so I can draw it, and it is a function. Oh, I forgot to write that down. Anyway, we've got this. Is it a function? I can put a vertical line here and here. Obviously it is. Now, with any of these graphs, you can, okay, so there's our domain. Remember, we've got to put an exclusion in there. With any of these graphs, if you want to, you can use your CAS calculator, okay, but if it says sketch, okay, then you'll still have to draw it, but you can use your CAS calculator to give you a bit of a hint. Now, this is new stuff here. So rewrite each of the following in what we call this function notation. So in the past, we've used y. So now we're getting, I guess it's more sophisticated maths, and we're turning this y into what we call an f of x. So if I jump across to, where are we? Up here. Okay, so this was what our equation is. So we want to rewrite this as a function of x. So we say f such that the domain, so this is a straight line, we know our domain, so this is our domain, is R, maps onto the real number plane. Okay, so we're dealing with real numbers. A function of x is 3x plus 2. So we're putting this as a whole mathematical sentence. So the function, the domain R maps onto the real number plane, where f of x, the function of f of x, we call it f of x. The function of f of x is 3x plus 2. So here's our 3c. So we've got this. Our domain is x is greater than 0. So this is why we use that interval notation and different sorts of notation. So we could rewrite this as a function of x. So we've got two ways. We can say the function such that the positive real numbers union 0 maps onto the real number plane. For the function f of x is 2x plus 3. So where that y is, we're changing it to f of x. You would have probably noticed that on your CAS calculators when you're putting in graphs, that it was f of x. So it's just a more sophisticated way of explaining your maths or mathematical sentences. And we've got, you can write it like that. Instead of positive real numbers union 0, you could write it like that. Okay, so they're pretty straightforward. What's the question? Which of these relations are functions? So once again, did we have to do 4? No, we didn't have to do 4. Okay, so this is where it starts to get nice and easy. So given that we've got the function f of x and 2x minus 3, find f of 0. So this is a different way to say, instead of sub in x equals 0, it's just sub in 0 because our x is already 0. This is sub in x equals 4, so it's just an easy, quick way of writing it. So if I was over here, if I've given that this is my function, f of x is 2x minus 3, find f of 0. So I just sub in 0, where I see my x, work that out. F of 4, so they're straightforward. It's only when we get down to these ones here. This time I've got my x, I've got where I see an x, I've sub in 1 over a. Where I see an x, I sub in x minus 1. So they're just a little bit more complicated. With these ones here, sometimes functions are labelled f of x rather than, g of x. So same thing here, so we just sub in 1 where we see the x. These ones here, subbing in 4a. This one where we see x, we sub in 1. This one will sub in 1 plus a. So just in this bracket beside the f, it's just replace that for an x. Then quickly jump down to 7 now. So this time, question 7, it says find the value of x for which the function has a given value. So f of x equals 5x minus 2. We've got f of x equals 3. So this is our y value now. So it's just if f of x equals 3, what does x equal? So where I see my f of x, I put in 3. I just solve it. So f of x equals x squared. If f of x equals 9, what's x? So you can see they're pretty straightforward to go through those. And do we go to 8s? Yep, and they're basically, we just keep flying through. So you should be able to work through that, and hopefully that'll give you enough hints to keep you going. Cheers.